Hi ladies and gentlemen, this is a GCSE video on upper and lower bounds. It's a Mastermind Alliance tuition video. It's mainly a video that will cover the Edexcel syllabus and it will also cover other syllabus boards as well. So what is an upper and lower bound? Let's take number 6.3. The upper and lower bound of 6.3 would constitute to either the highest number, so the upper bound, so the highest number that would round 6.3 and the lowest number that would round 6.3. So first of all, let's look at the lower bound. So the lowest number that rounds to 6.3, let's get the text button up. So the lowest number that would round to 6.3 is 6.25. So to one decimal place, if you used to round that 6.25 to the nearest one decimal place, that would be 6.3. The highest number that would round to 6.3 would be 6.34. 99999 recurring forever. So a reoccurring 9. That's a bit difficult to deal with. If we've got sums and we're dealing with maths, we need to add something to that. We need to subtract something to that. It's going to be a lot to deal with. So what mathematicians generally do is they'll change that 6.349999 recurring to 6.35. So that would be the upper and lower bound of 6.3. Now, let's take into account 0.93 correct two decimal places. So this time we're doing 2 decimal places. Again, let's look at the lower bound first. So the lower bound of 0.93 would be 0.925. Because if you used to round that 0.925 to 2 decimal places, that would be 0.93, which is what we want. Now the highest number would be 0.939 recurring. Again, this is a bit of an issue. It's not something we really want to deal with, all these 9s. So you'd round that to 0.935. So that would be your upper bound, that would be your lower bound. Now I know you're asking, and you're thinking, hold on, Jason, you said correct 2 decimal places. There's 3 decimal places here, there's 3 decimal places here. Remember, if you used to round these to 2 decimal places, both of these would make 9.3. So this is the answer, and this is the answer. Now, let's look at this one. What is the upper and lower bound of 71 correct to significant figures? So the lower bound will be 70.5, because if you used to round that up, that would become 71, and that would obviously be 2 significant figures. The upper bound would be 71.5. Again, we know that the actual figure would be 71.49 recurring, but 71.5 would be sufficient. Okay, so we've completed significant figures. We looked at 2 decimal places. We looked at 1 decimal place. Let's have a look at addition. So let's say you had the sum 5.2 plus 6.3, and they want you to find the answer to 1 decimal place. Let's put an equal sign and make it a bit neater. Okay, So we're finding that to one decimal place. In order to find the upper bound of that sum, we need to find the upper bound of each digit. So the upper bound correct to one decimal place of 5.2 would be 5.25. And the upper bound of 6.3 would be 6.35. And when you add them together, you'll get the answer 11.6, which is correct to one decimal place. Let's have a look at lower bound. So the lower bound of 5.2 would be 5.15, and the upper bound of 6.3 would be 6.25, the answer being 11.4. So that's the lower bound answer, and that's the upper bound answer. Let's take into account subtraction. It's exactly the same thing. So if I've got the number, let's just say 6 minus 4.73, remember to put the equals in this time, and we want to find the lower and upper bounds of these answers. So the upper bound of 6 would be 6.005. Why have I done that? Because we want it to two decimal places. So two decimal places is 6.00, and the upper bound, sorry, I'll think about the upper bound first. The upper bound would be 6.005. So the lower bound of, sorry, the upper bound of 4.73 would be 4.735, and that would equal 1.27. So this is the upper bound answer. The upper bound of 6 would be 6.005, because we're doing it to two decimal places. And the upper bound of 4.73 would be 4.735. And the final answer would be 1.27. Okay, the lower bound would be 5.095 minus 4.725, both of which are the lower bounds, and your answer would be 0.37. So this is your upper bound answer, and this one here is your lower bound answer. Okay, so multiplication, again, exactly the same procedure as upper bounds and lower bounds of addition and subtraction. Bear with me because division is different. So let's take into account here 2.7 times 31.5. And we want that correct to one decimal place. So let's first look at the upper bound. The upper bound of 2.7 to one decimal place would be 2.75. I'm going to multiply that to 31.55, and the upper bound answer would be 86.8. And the lower bound answer would be 2.65 times by 30.55, and that would equal 80.95. Now remember, we want this to one decimal place. So if we used to make that to one decimal place, that 80.95 would become 81.0. So your actual answer here is 81.0. Okay, so division of upper bounds and lower bounds. This is when things get a bit different. Let's take, for example, the equation speed equals distance divided by time. And let's say that we're in a car and it is traveling at excuse me, and we have traveled 35 miles in 4 hours. What is our speed? Now, in order to find the upper bound, so the answer, we'll need to do 35 divided by 4. But we want to find the biggest possible answer that 35 divided by 4 will give us. So for this, I like to imagine a cake. What we want to do is we want to have the most amount of cake, and we want to cut that cake into slices and share it so that people have the biggest slices. So in order to share a cake with the biggest amount of slices, you need to share it out to the smallest amount of people. So you don't want to share your cake out to 2 people, or there'll be too many slices, right? You want to give the least amount of slices to get the biggest answer. So in this case, what you do is you get your biggest cake, which would be 35.5, and you want to give it to the least amount of people, which would be 3.5 hours, which equals 10.1 to 1 decimal place. The lower bound, what you want to do is you want to get the smallest amount of cake that you can get, which in this case would be 34.5. And you want to divide that out to as many people as you can to get the smallest slices, which should be 4.5. That gives an answer of 7.7. Okay, so let's take into account this last question here. What are the upper and lower bounds of 160 to the nearest 5? So the upper bound of 660 to the nearest 5 would be 160.24. No, recurring. So it's perfectly acceptable to call that 160.25. That's the upper bound. And the lower bound would be 157.5. So the reason being, if you imagine 160, the next 5 would be 165. So we don't want to go around to the next 5. We want to around to 160. So the highest number that would do that is 160.249 recurring. The lowest number would be 157.5. Anything lower than that would round down to 155. Anything higher than that would round up to 160, which is what we want. So I think the most important learning point, and something that gets tested on quite a lot in GCSE questions, is this division. So just remember, if you want to find the upper bound, we divide the biggest number, so the upper bound, divided by the lower bound. If we want to find the lower bound, we need to do the lower bound divided by the upper bound. And that will always give you your answer. Okay, thank you.